From South Bend, Indiana, welcome to 3 Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Of course. So electron beam is working under vacuum. First of all, that's a big advantage. You don't have oxygen issue. The second big thing is it's much more powerful than laser, and you can melt almost any materials or any metals. So you can keep the heating of the build plates up to like high temperature, like 1200 C or even 1400 C, and this means you don't have residual stress problem.
That was Mohsen Taheri Andani. Mohsen is an assistant professor in the Department of Mechanical Engineering at Texas A&M University, with a courtesy appointment in material science and engineering. He received his Ph.D. degree in mechanical engineering from the University of Michigan in 2022. Under the supervision of Professor Amit Misra, his research focuses on establishing the interrelationship between processing, microstructure, and properties of metallic materials. Mohsen has worked on several material characterization projects and has published over 35 journals and articles in the area of metal additive manufacturing, material characterization, and mechanical properties of materials. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials qualification or data management related to additive manufacturing, reach out to our team through our website or via email at info@3degreescompany.com.
Cool. Well, Mohsen, thank you so much for jumping on the podcast today. We're really excited for the conversation. We've gotten to know each other kind of over the last couple years here on various kind of events and proposals. So I'm excited for the conversation and kind of digging into your background a little bit more and sharing that with the audience. So I like to start very much at the beginning of kind of what people are about and what kind of get to know that better and share that for the audience. So where were you born? Where'd you grow up? And kind of do you have a specific memory that kind of helped propel you into the engineer that you are today?
Yeah, thank you. Thank you for inviting me to this podcast. So I'm born in a city named Isfahan, very historical city. I started my I think my educations in a university named Isfahan University of Technology. I started in mechanical engineering in the first place, and I remember the one of the reasons that I started that, actually I remember my brother also did his undergrad in mechanical engineering, and that's what I love to see that, and I love the path he went through. So I like it a lot. So I also started mechanical engineering. And then I started my master degree in University of Toledo, Ohio. And in that university, I started working with a faculty named Dr. Muhammad Lahiniya in 2013. And he, at the time, he got a grant from Ohio, the state of Ohio, to acquire a 3D printer. And at the time, it was a 3D system, one of those old versions. But it was very good, like it was working very well for us. And then we started looking on printing new alloy, like nickel titanium, I remember at that time. But it was interesting when I was thinking about those times that every conference or every meeting I attended, we need to explain to people what is additive manufacturing or what is 3D printing. It was not well known as everyone knows, oh, this is how metal 3D printer works. So we always have few slides giving people, oh, this is laser powder bed fusions. And I remember like 3 years or 4 years later, my advisor told me to skip those slides from now on, because people already know that. Don't go through layer by layers process. So it's not going to work anymore. So I did my master there, and then I moved to University of Michigan because it was 45 minutes from Toledo. I started working there, and I did my PhD and postdoc there, and it's mostly focused on materials part, but still I tie into additive. Over there, I worked with other system, DD and the other laser powder bed system. And then right now, here I am in Texas A&M.
And so mechanical engineering is a huge field, right? And so when you were kind of getting started, did you have a specific, I know you kind of the focus now is additive, but did you have like uh, a seed of inspiration or something that like really kind of pulled you in terms of what you liked? Was it the like mechanics of materials? Was it putting car engines together? Was there something that that really kind of piqued your interest?
Yeah, so I was mostly interested on the metallurgy part, like the solid or the solid mechanics we call here. So let's say when you have a metals, I mean you do like you understand the property of that, but why it happens, like how you can improve it. I always like that area, like because of course as an undergrad students we passed different courses, but one of them I remember was solid mechanics, and the teacher like explained why these process happen, what the mechanisms behind, and I like that the most, and I think those courses give me the motivations to continue the grad schools and focus still on solid mechanics.
And you want to talk a little bit about what your PhD was and kind of
Oh,
what
of
the
course. Yeah, so I did my
topic?
PhD. Yeah, of course. I did my PhD in Michigan, as I told, and my advisor was a material scientist. His name is Amit Misra. And I was working very depth in materials. I was working on magnesium alloy. Magnesium alloy is a lightweight materials that's very interested by a lot of industry like aerospace, the car industry, of course. Michigan is close to those GM, Ford, and these companies. And but it's still there are lots of things to learn. For example, we need to learn that when you have magnesium alloy, how the strengthening mechanism look like. So when you pull these materials, what happened inside of these materials. So I try to learn about like the microstructures and the grain boundaries in those magnesium alloys, and try to find a way to quantify the strengthening mechanism. So it's I remember I was in microscope rooms, so look into the microstructure of these materials, try to learn how these materials behave, and try to quantify them, because I always like to I'm an experimentalist. I like to quantify the strengthening of each boundaries. And then we had a strong team in computational there that we tried to develop an open source code named Prisms that helps the community to simulate the property of these materials. So I try to work with a computationalist there. All these I'm explaining, it's a little bit different than the additive that you're thinking. But the materials knowledge that I learn right now is very helpful for me. So I can leverage from those understanding, and when you're thinking about printing or additive, I can think about how I can quantify the properties of the materials from the microstructure.
And with that, I mean, during that time, I imagine you're going to conferences and trade shows. Was there anything that stood out as you're kind of trying to keep on top of what's new and what's the
Yeah.
latest? Like, were there highlights
Yeah.
from that experience?
Yeah. So in 2000, I mean, I always um, I remember in 2015, I was working with a company at the time in Michigan, SLM Solution, for a few projects. And I was a first year PhD student, and I submitted an abstract, I remember, to SFF, Solid SFF in Austin. And it was very interesting to me at the time that they selected my abstract as a keynote. And it was a big kind of motivation for me. So I went there, like big name was there, and I was the first year PhD students and give a keynotes on spattering, because at the time people knows about the spattering happened during laser powder bed, but not that many research focus on that area. So people like it, and I give a keynotes. It was very interesting for me to see like the community give credit even to PhD students. So and that conference to me was very interesting. So SFF is one of those I always remember because of, again, one of them, of course, because of what happened specifically to mine. And the other conference I attended, and it was very surprising to me, it was Rapid. So when I attended these Rapid conference at the time, it was very interesting to see how the community are growing and the technology is there. So these two conferences always motivate me, and then I like it to, oh, this is like something I want to continue my work.
Yeah. And so what was it about the kind of academic setting? I mean, you're at there now, but like what do you like about it? Like what are, I mean, maybe even for listeners who aren't familiar, like with the process of getting a PhD, kind of what was it like for you? Like, are you taking classes? Are you doing research? Is it a combination? Like, what's the time period look like? Maybe just like at a high level, like, hey, what does it mean to get a PhD and do this research?
Yeah, of course. So, so there are two ways that you can have your PhD. One is after your undergrad, you can apply for your direct PhD program. Most of the school has those programs. It normally takes 4 to 5 years if you apply right after your undergrad. The other way that you can have 2 year of master or 1 year of master, and then have a 4 year program of your PhD. So every university has its own requirements. For example, at Texas A&M, if you should either pass 96 credit if you go with a direct PhD. The other program is 64 credit. So it's a combinations of course and the research, but PhD is mostly toward your research program. So it means like you need to have an advisor, and you choose a specific topic that you are interested to work on, for example, on additive, and then try to learn about the background areas, and then try to narrow down on a specific area and try to push it forward, like learn about the problem, the challenge, and then learn how to think kind of as a scientist and think about how I can fix this problem from the scientific perspective. So I think during the PhD, it's you will learn a little bit different way of thinking, mostly in my opinion. So you learn, like, if you find a problem, even in industry later on, how to look on like the literature, learn about what other people have done, how to analyze them, and then you will learn how to resolve that problem, how to leverage from other works and also from your expertise to hopefully fix that problem. And also you will learn a lot on how to write papers, write reports, how to present efficiently to the others. So you will get lots of opportunities in university to learn those. And in universities, it's like, because it's a big, normally there are big institutions, lots of resource and opportunities there. So I think it's a good opportunities for specifically young generations to spend some time in universities beyond their undergrad. So because undergrad, you keep having lots of courses, you never tie into one specific program or area. But during your PhD, it's the time that you get matured and you learn how to think as a scientist, in my opinion.
And so as you were getting close to the end of your PhD at Michigan, what was your thought process? Did you know you wanted to be a professor? Did you think you were going to go into industry? Was there something else that you were considering? What was your mindset then?
Yeah, so honestly, I like the way that my PhD advisor, mentor people. I always admire him because he always tried to help other people. So because during your PhD time, you would see lots of students that they have lots of hope, lots of motivation, lots of like energy. They want to have a big dream, and they need some opportunities. And at those times, these are the faculties that would help the students, will like kind of give them the opportunities based on, based on the resources they have available. And that's very, very interesting and very enjoyable, I think. Beyond that, you also have the opportunities to teach the new generation some new concept. For example, you can teach them about additive, you can teach them about the basic of solid mechanics or all these areas. So teaching is also something very interesting. So by the end of my PhD, because I stayed in grad school for about 8 or 9 years, uh, I got my first master, then second master, and then got a PhD. Um, by the time of my end of my PhD, I knew I want to stay in academia and then try to somehow continue the way that my advisors go. But also, I like industry. I like because I work with lots of industries in Michigan. But I want to work with them in a different angle, not as a staff or like inside. So I was thinking of working with industry from the university. So learn about their problem, learn about like what is challenging there, and try to see if we can help them in the universities.
Yeah. And so with that, I mean, how'd you find Texas A&M?
Oh, Texas A&M is a very big universities. Lots of resources are here. So even, for example, in additive manufacturing, which is our interest, you can find easily 7 or 8 faculties are actively working on it. In mechanical engineering, we have more than 120 faculties, and the number of the students is also like it's incredible. Lots of opportunities is here, so I like it a lot. So you can easily find good resources for your own research, as well as like lots of students are interested to be involved, and you can have opportunities to mentorship, and as well as like teaching others. So I love Texas A&M, and there's a very good mentality here, and to try to help people to grow. That's very good. And it's also very good opportunities here for people who like metal additive manufacturing, because a lot of the universities, in my opinion, they keep hiring the same area, but they don't notice that, oh, you need to make sure that the hire is kind of complementary to each other. So if you come to here, you will see we have people who are focusing on, for example, alloy design. We have people who are working on DED, but also we have people working on the other aspect of it, monitorings, and then, for example, the other technique of additive. So all the groups together is a big program, but we collaborate very well together. So it's very enjoyable to work at Texas A&M.
And maybe dig into the mentor piece a little bit. So now being on the other side, what is your kind of mentorship approach, leadership approach with students that you're working with? You have kind of maybe first question is kind of what do you look for when you're kind of looking for your own PhD students or hiring students to work in the lab, but then more like what's your kind of mindset on helping them grow? What do you see has been successful so far?
Yeah, so the way that I always like to see the students is so when I talk to them or interview them at the first time, I want to see if what is their goal, what they want to get through this PhD program. So importantly for me is students need to have the motivation to learn. So need to think about how they are the future star in their field. And I always like to train people who can be independent of me. So it's not like, because there's a way that you can have a micromanagement way. So you keep talking to people, keep monitoring them, keep giving them the macro guidance, but it is not the way that I was thinking always. So when I have my PhD students, I always give them a big overview of the problem and let them think and back to me and say, hey, we read this paper and this is like what I find challenging. And then we can have some discussions and say, oh, this is like, this is correct or not, or like give them some more ideas. I always like, and when I'm mentoring my PhD students, I always think that, oh, these are the next generations of either leaders in the universities or industry. So I always think about them like that. So trying to um, um, uh, kind of adjust my mentorship that way to give them more opportunities, try to let them to be independent, and let them think. So that's very important for me to make sure that they are people that can think thoroughly and then talk and give them their solutions or methods to the different approaches. So one more thing I want to say is one of the approach I'm using, which I liked a lot. We call them as a journal club. So every week we have two meetings. One is group meeting. People come and present their idea. That's of course, or their research work. So, but there's a meeting we have, they call the journal club. The way that it works is we assign one journal paper to all the students, like one journal papers from other groups, not our work, and ask the students to read that paper, find the strengths of that papers and also the weakness, and bring it to the tables. And next week when they present, every person needs to say, oh, I read this paper, I find these strengths and these are the weakness. And then they start kind of having a discussion about that. So this way students learn how to like kind of review one scientific work, and also it helps them a lot to learn how to think, I think. So that's what I learn a lot in during these meetings.
And so maybe talk a little bit about kind of the focus of your lab. What are the topics that you're interested in researching now, and kind of the areas that are exciting you about, you know, not only additive but other spaces and materials that you're looking at?
Yeah, so it's a very good question actually. So for about 10 years I was working on mostly materials part and laser powder bed specifically. But when I get into the academia, I was thinking, okay, I need to look on different areas and see where is the gap and which areas still need more work. So I choose a few different pathways, three pathways actually in general. One, I learned out that there are lots of good opportunities still and needs time industry specifically on the processing additive or monitoring additive, specifically laser powder bed, but not only from from like using camera only. So, but beyond that, like when you using, for example, the monitoring technique like OT cameras or all these cameras to monitor the process, what type of fundamental information you can get from them, not only like understanding that there are some defects there. So we want to learn that first of all, can we make it, like for example, when you get an OT images or thermal images, can you learn about the microstructures as well? So because those microstructures will help you to understand the mechanical property. So I found that first of all, monitoring laser powder bed fusions or also the other additive technology is still need more work to be done, specifically correlate those monitoring techniques to the microstructures and mechanical property. And I had this fortunate to be involved with American-made projects in these areas. So I got some funding over there and some projects, so which we are actively working on it. The second trust that I learned now that it need more attention is electron beam. So electron beam power bed fusions was like in the fields for a period of time, then it goes down. But it's still right now with the new technology that grow, there are lots of new opportunities here that we need to focus specifically on additive manufacturing of high temperature alloys like refractory alloys. So those needs knowledge on materials part, on the process by itself, and that's something I really enjoy working on it. So that's why I acquiring a new electron beam system, and we start printing tungsten and titanium alloys and so on. And the third thrust, which is another additive technique. So I work with a company, local company in Houston, that they have a solid state additive technique, melt. And I noticed that the melt is growing up and it's very interesting for lots of community, but still our microstructure information is very limited. So mostly this technique is developed and kind of show to the people that it's worked. But lots of work need to be done in terms of like understanding exactly what we are printing, what is the microstructures, what is the property. So then I involved with working with that company as well in Houston, and we are working on some project together.
And so go back to the electron beam conversation. What about it is good or better or unique compared to laser powder bed? I know it's been around for a long time, and I've seen it mostly in like the medical space is kind of where I've seen a lot of medical or applications of electron beam. But can you talk about kind of why the resurgence, why the interest?
Of course. So electron beam is working under vacuum. First of all, that's a big advantage. You don't have oxygen issue. The second big thing is it's much more powerful than laser, and you can melt almost any materials or any metals. So you can keep the heating of the build plates up to like high temperature, like 1200 C or even 1400 C, and this means you don't have residual stress problem.
Yep.
So no residual stress is there. You're working with electron beam and under vacuum. So then it will give you this opportunity to work with titanium that, as you mentioned, for implant, because you don't have any issues with impurity of those implant. And also you can print high temperature material like refractory alloys like tungsten, like C103, niobium, molybdenum, those alloys, because they have lots of good applications. But liquid powder bed is not. I think it's not the right way to print refractory alloys because of lots of cracking issue that you might see during this process. So it is not. I mean, of course, laser powder bed fusions has its own advantages, and then some of the alloys working much better with laser. But electron beam also has a series of material that you need to use this technology for those materials.
Sure. Yeah. So couple last questions. So one is kind of we're in middle of the summer 2024. Rapid just happened. The industry is kind of going through kind of ebbs and flows. What is still exciting you about the space or opportunities that you see in terms of your work or applications of your work in the AM space?
So I think one already when I attended Rapid this year, compared to last year, actually, I noticed like industries are looking on some technology that it's going to work at the end. So specifically on the wire-based additive. So for a long time, I think lots of companies invest on powder-based additive, but still it was a big question that all of them will stay in the market or not, because do we really have that many of parts that need to be fabricated by powder bed fusion, laser powder bed fusions? And eventually, when I attended this year, I noticed some of those companies attended last year are not coming because they learn about, oh, this is like maybe not be a big market on that area. But instead, this year I see wire-based companies get into the market more. That means there are some good, I think, future, in my opinion, for wire-based additive, because
Is
it's
it cheaper, you think, or is it
the wires, I mean, of
faster?
course, having faster, and the wires is more affordable. And also, you don't have that many problem of in terms of, for example, depositions,
Yeah.
defects in wire-based additive. And if you need resolution, if you don't need that much of resolution, you actually don't need to go with powder bed, in my opinion, with powders. So it's kind of more realistic in some of the application. Of course, not all, but I noticed there are some new initiatives there, and then start people thinking about this. And also I see like more and more novelty. For example, people use blue lasers, green lasers. So those are also very interesting. So to me, that the university understand. I mean, the industry understand like infrared lasers is not going to work with aluminum. So let's move it forward. Like let's think about blue laser, green lasers, and then it helps them to improve the quality of their product.
Awesome. So last question that I've been asking recently has been, is there a book, a podcast, or something that has given you inspiration that you'd like to share with the community? Um, Maybe a journal paper, given that you guys are reading journal papers every week, but is there kind of something that's helped you always kind of ground your kind of goals and helped you kind of progress in your career?
Yeah, so it's a good question. Let me refer to one of your podcasts because I listened to some of them, and I like the way one of the podcasts that you have with Medina in UTEP.
Uh-huh.
I like that. So the way that he was talking about his own experiences about like and his stories in UTEP and how it grows, and then they didn't have any AM, and then how it grows, and then right now they are pioneering in our field. But how this story started, it was very interesting for me. So I listened to that podcast 2 times, and it was very interesting for me. So I think that's I would recommend people to watch that podcast and then see how a field can grow and how people's like can impact on this area.
Awesome. So one last question. So if people like, how do people work with you? How do people work with you as a company or as uh, if they have an idea? Like, what are different mechanisms that you've seen or that you are looking for in terms of collaboration? Or are you looking for collaboration? Maybe the first question, but assuming that's a yes, how do people work with you?
Yeah, of course. So we all, as a universities, we always like to work with industry because, in my opinion, additive areas or additive peoples, or in general, not only additive, in general specs, like it's very good for industry to work with universities from both like helping them to grow in terms of their technology as well as like in terms of workforce development. So we are always looking for collaboration. I mean, I'm working with different companies right now with EOS, local company here, Behind, Additive, and all these. Um, we are always open to collaboration. We don't need to have money, so it's very important. So you don't need to sponsor us right away. So we can start working on some topics and build up some new ideas. And then I think if we when times comes, the funding also will come, and then we can also always let grow. So the universities like us, we already have PhD students and motivated people that who wants to learn. So I think that's very good at opportunities also for the industries to collaborate and always know like their people likes to learn, and that could be a good start.
Awesome. Cool. Well, thank you so much for joining the show today. Excited to kind of see where your lab goes in the coming years and see all the good work that you're continuing to do. So thanks so
Thank
much.
you. Thank you so much.